Okay, we're looking at linear regression and least squares lines and so on and so forth, scatter plots. First of all, this question is asking you about calculating Pearson's R correlation coefficient. Okay, it leaves out the Pearson part in here. Pearson's R gives you the strength of the linear relationship that you have. And it ranges from -1 to +1. Okay. So in your book, it shows you some examples of what what these look like. A scatter plot of -1 exactly would be something like, okay. That means from left to right as this is x. So if you had a scatter plot here. And you had a line that went directly through that. I'm going to try to do this. This would be R equal to -1. We hardly ever see that. So +1 would be as x increases, y increases. I'm trying to put the scatter plot in here exactly. You're probably going to see things more like let's see if I did this. And the line of best fit, or the least squares line, or the regression equation. So there's 3 different names for it: line of best fit, least squares equation, or the regression equation. I might have the best line that goes through this is like maybe right through here, and this might be that R is equal to 0.8. Okay, again, because again it's positive, so what if I had something that looked like this? This one might be like R is -0.7. If you had something that's kind of like all over the place, there's no linear relationship. I can't draw a line there. This would be something like R equals 0, or R equal, or R is equal to, I guess if it had kind of an upward pattern, maybe going here. R equal maybe 0.1, because it's kind of looking positive. I have this here, and I actually developed this myself. Typical interpretations of R square of R. Okay. So if R is ranging from 0 to about 0.2, or 0 to -0.2, we may say that there's no negligible correlation. We may say there's no linear relationship. So again, either positive or negative. If your R is between 0.2 and 0.40, or -0.2 to -0.40, we may say there's a low degree of correlation, or there's a weak linear relationship. If R is between 0.40 and 0.60 and -0.4 to -0.6, it may be regarded as a moderate degree of correlation. We might say there's a moderate linear relationship. R ranging from 0.6 to 0.8, or -0.6 to -0.8, we might regard that as saying it's a marked degree, or there's a somewhat strong linear relationship. And in between 0.80 to 1, or -0.80 to -1, we would say there's a high correlation, or we might say that there is a strong linear correlation. Okay, so just wanted to point that out. Okay, so we're going to use StatDisk to do this, to find R for us. So I'm going to copy, and I'm going to bring this over here, and I'm going to the sample editor. I'm hitting Control V. Double check, make sure it copies in okay. Analysis, correlation. we're not worried about the significance right now. You can leave that as is. X is going to be in column 1 and Y is going to be in column 2. So our correlation coefficient R is 0.75579. That's pretty strong, isn't it? So according to what we'd say here, we would say there's a somewhat strong linear relationship, and since it's positive, it's going to be a positive linear relationship. So we're going to round this to 3 places. 0.756. Okay, let me know if you have any questions. Thanks.